Hi guys, welcome to a new video on differentiation under Math SL. In this video, we shall introduce stationary points. I shall solve the 4 questions on the screen in front of you, and I shall begin with question 1 shortly. So the first question that we shall solve came in paper 1, November 2002, question 8. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. Bear in mind that even though this is a paper 1 question, you are allowed the use of a calculator, since in old exams, paper 1 was a calculator paper. So you can use a calculator while attempting to solve this. So we are given a function y equals x cubed minus 10x squared plus 12x plus 23, and we are told that there is a maximum point between x equals negative 1 and x equals 3. We are asked to find the coordinates of this maximum point. So you should know that a maximum point is a turning point or a stationary point. Hence, at any turning point or stationary point, the slope is 0. So we are looking for a point where the slope is 0. You should also know that the slope of an equation or a function is given by its derivative. So y dash has to be set to 0, and we need to find the value of x that makes this happen. So the first thing we're going to do is we're going to differentiate this function right there in order to obtain y dash. So this is simple differentiation, and you get this derivative function in green right there. So there are multiple ways in order to solve this equation. You can either factorize manually, or you can use the GDC to find the x values. This is simple enough. So the values of x that make this equation equal 0 are 2 over 3 and 6. Of course, the 6 is excluded because we are given that the value of x that we're looking for lies between negative 1 and 3. So we shall choose the 2 over 3. So in order to find the y coordinate of this point, bear in mind that you're not only asked to find the x coordinate, you are asked to find the coordinates, so both coordinates. In order to find the y coordinate of the maximum point, we shall simply plug 2 over 3 into this equation right there. Of course, if you have to do this manually, you would probably take 10 minutes of work. So thankfully, this is a paper where the calculator use was allowed. So you simply plug in 2 over 3 into this equation, and you obtain the y value of 725 over 27. Now, there is a very quick and nice way to actually find this answer using the calculator without even having to differentiate. So let's take a look at that. So I've typed down the original equation onto my calculator: x cubed minus 10x squared plus 12x plus 23. This is the original function given in the problem. I shall click on trace. This is the graph of the function. I shall click on second, trace, find the maximum value. Now, I need to give the calculator a left bound, so obviously the maximum value is somewhere where the cursor already is. So the left bound will be somewhere to the left, the right bound shall be somewhere to the right, and the guess shall be somewhere here. And the calculator tells me automatically that x equals 0.66667, which is 2 over 3, and y equals 26.85, which you shall find to be equal to this number right there, 725 over 27. So you could have actually done the entire problem on the calculator and maybe provide just a rough sketch of the graph, pinpointing where the maximum point is, which is right there. So this concludes our first question. Take a minute to write this down if you will, and I shall begin question 2 shortly. So question 2 came in paper 1, November 2009, question 5. Kindly take a minute to pause the video, attempt to solve, and the answer shall follow through shortly. So we are given the function f of x equals x squared plus p over x, and we are asked in A to find f dash of x, so this is simple differentiation. Of course the p acts like a regular constant, so you can just assume it was a 5 or something. I've rewritten the function in black here, right there, in a more friendly format to differentiate. So instead of having x in the denominator, I've raised it to the numerator and added a power of -1. This should help me with the differentiation. And of course, the -1 multiplies the p, giving me -p, and the power is reduced by 1, giving me power -2. Hence, the derivative function in a nicer format looks like this: 2x minus p over x squared. In question B, you are told that there is a minimum value of f of x when x equals -2. And we know that minimum value means that f dash equals 0 because this is a turning point or a stationary point. Hence, we are going to set f dash to 0, also setting x to -2. Hence, f dash of -2 equals 0. So I'll just plug -2 into the x values right there and right there, or actually right there and right there. Excuse me. So let's evaluate this. So 2 times -2 gives us -4. P over -2 squared is p over 4, and this negative sign right there is preserved as it is. Hence, -4 equals p over 4, and p equals -16. So, take a minute to copy this down if you will, and I shall begin question 3 shortly. Question 3 came in paper 2, November 2016, question number 2. Kindly take a minute to pause the video, attempt to solve, and the answer shall follow through shortly. So in question A, I'm required to find the coordinates of point A, which is the local minimum point. So I shall just use the GDC to do that. So I've written down my function on the GDC. I've set an appropriate window for my graph, and I shall click on trace to see how the graph looks like. So there is my graph, and now I want to find the coordinates of the local minimum point. So I shall press on second, trace, minimum. I need to find a left bound, so somewhere to the left of my minimum point, right bound, so somewhere to the right of my minimum point, and a guess, so right there. And the minimum point is 2, -3.6. So I've written the answer right there. Let's move on to question B. In question B, I'm asked to sketch the graph of f within this domain, clearly indicating the point A, which is my minimum point, and then to sketch the tangent to the graph at A. So let's take a look at the calculator drawing. So there is my function as it is. We had already written down the equation for question A. I've adjusted my window to suit the given domain. So x minimum is -3 and x maximum is 3. As for the y values, I've just set it slightly above 4 because this is what they've provided in the graph. So I've set it from -5 to 5. Next, I shall click on trace. There is my function. I just need to draw this function onto the grid, making sure to mark the minimum point right there, as well as draw a tangent line at the minimum point. And you should know that the tangent at any stationary or turning point is horizontal. So since it is a turning point, hence I expect the tangent to be a horizontal line that barely touches the curve at point A. So this is what your sketch should look like. Let's take a look at the marking scheme version of the answer. So it kind of looks the same as what we have on our calculator. Excuse me. So this is the marking scheme version of the answer, which kind of looks similar to what we got on our GDC. And let's take a look at the criteria for grading that they've provided. So you want to have a correct cubic shape, which is the inverted S shape that is apparent here like this. And if this correct shape is there, then you get marks for the following. You want your graph to pass through the origin as well as point A. So the graph has to pass through 0, 0, and it has to pass through the minimum point right there, which has coordinates 2 and negative 3.6, if you remember. You are awarded 1 mark for the correct endpoints, and these depend on the domain that was given in the question, negative 3 less than x less than positive 3. And you are awarded a mark for a maximum point. So just without having to identify it, just the fact that you have a maximum point. Finally, in the second question, double I, you are awarded 1 mark for a horizontal tangent line that passes through the minimum point. So take a minute to copy this down if you will. I shall begin question 4 shortly. So the fourth question that we shall tackle came in paper 2, May 2012, time zone 2, question 9. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So you are given that f of x equals ax cubed plus bx squared plus c, where a, b, and c are real numbers. The graph of f passes through the point 2, 9. And you need to show that 8a plus 4b plus c equals 9. So since the graph passes through this point, hence we know that when x equals 2, y equals 9. And y is the same as f of x. So what we shall do is we shall substitute f of x with 9, and we shall substitute x with 2. So this x and this x right there. So let's take a look. So when x equals 2, y equals 9, hence the 9 was put in place of f of x, and the 2 was put in place of each x in the equation, and this gives us 9 equals 8a plus 4b plus c, which we were required to show. So let's check question B. The graph of f has a local minimum at 1, 4, and we need to find 2 other equations in A and B and C. So since the graph has a local minimum at this point, we can derive 2 pieces of information. First of all, that the graph passes through this point. Hence, when x equals 1, y equals 4. So we shall repeat the same procedure we implemented in A, however using 4 instead of f of x and 1 instead of each x. We also know that a local minimum is a point where the slope is 0 and hence f dash is 0. So we also know that when x equals 1, f dash equals 0. So let's take a look at how to use this information. So since it's a minimum point, f dash of x equals 0 when x equals to 1. Hence we shall differentiate this function, obtaining the blue function right there. Then we shall replace x with 1, and set f dash to 0, then we need to solve this equation 3a plus 2b equals 0. So this is the second equation that we have derived. And like we said, we also know that when x equals 1, y or f of x equals 4, so I shall substitute the 4 instead of the f of x and the 1 instead of the x. And this shall yield a third equation, which is a plus b plus c equals to 4. So I've obtained two other equations in a, b, and c as instructed in the question. So let's check question C. I am asked to find the value of a, b, and c. So I'm asked to solve the equations together. This equation right there, as well as the two equations that were obtained in B. So we have three equations written in black right there, and we need to solve them. There are three unknowns that we need to find out. So the way to do this is to write two of the letters in terms of the third. So what I'm going to do is I'm going to write A in terms of B and C in terms of B as well. So what I've done is I've used the first equation to isolate the A and write it in terms of B. Then I've substituted this value of A instead of the A right there. And now I have this second equation only in terms of B and C, as you can see right there. So I shall write C in terms of B. I shall isolate the C. So what I've done is I've added these two terms together, giving me this term right there. And then I've isolated the C and written it in terms of B. So now I have A in terms of B and C in terms of B. So I shall simply substitute the A and the C in the third equation with their equivalent forms in B, using the other two equations. So this is the equation that we obtain, and I simply need to add the b's together, the three terms containing b, getting this red equation right there. Then I need to isolate the b and solve. Once I've obtained the b, which turned out to be -3, I shall simply substitute the -3 into this equation to give me c, which turned out to be 5. And I shall substitute the -3 into this equation as well to give me A, and A turned out to be 2. Of course, here we already know that B is -3, and hence we figured out C and A. So this actually came first, so forgive the mistake. Anyway, this concludes our question. So take a minute to write it down if you will. This concludes our video as well. I hope you have found it useful.